Welcome back, campers. On this episode, I'm going to take a crappy portable washing machine and I'm going to convert it from 120 volts AC to 12 volts DC to run off of my solar battery bank. There are plenty of crappy portable washing machines online. They are all junk. They are all made with junk components. You can get them as cheap as $120 plus shipping, or the sky's the limit. Some are $300 with free shipping. Underneath, there's a lot of just the same junk components, which is fine because I plan to rip most of them out and replace them with 12 volt junk components and see if I can make this work at the off-grid cabin. The main components I'm really interested in are the drum, the mechanism for spinning the drum with the motor, and the drain and fill lines. I was able to actually score this model washing machine used for about 75 bucks, which makes me feel a little bit better about hacking it all up and ripping out components. This is the reassembled version, and I'll take you through. Replaced it, the motor and the motor controller, two 12 volt solenoids for the drain and the fill, some blocking diodes on the motor controller. It did not have it built in to prevent kickback from this DC motor. Tearing down the washing machine, taking out all the 120 AC components and replacing that AC motor with this Amazon 350 watt DC motor. There's a pulley. It's cast aluminum. I had to bend some of the fins off of it, or break them off rather, removing all the electronics because they're AC, and anything wired in on that AC circuitry inside. Motor controller, pretty straightforward. 12 volts in, 2 leads to the motor. Underneath the top of the washing machine is the fill, so that's going to be the water inlet. Replacing that with a 12 volt solenoid so I can flip a switch or run a relay that will allow to turn on and off that fill. So this is the original washing machine, just looking at the internal components. It's got the AC motor, it's belt driven for the drum as well as the agitator. You can see this drain mechanism, which I'll talk about later. And then there's a switch that moves for the agitator. AC motor removed. You can see those fins on the belt pulley. The new DC motor is actually a really good fit for the sheet metal motor housing that's in there and the brackets. So trimmed those fins, put the pulley back on, secured it to the shaft, and then put everything back together. All right, time for a first test. Quite the contraption going on here, but I need to test it, so I need a water hookup, I need a drain. These were designed to have a gravity drain, so there's no pump to evacuate the water. I have it perched atop the dryer next to the connections. I've got water inlet hose coming into that new 12 volt solenoid, and then drain hose that just gets shoved into the wall drain for the washing machine. I hope everything's hooked up right. We're about to find out. My trusty 5 volt, 12 volt bench power supply. Got about 30 of these laying around. So this is going to provide 12 volts. I'll test this again on the battery bank, the 12 volt battery bank. Okay, and we have power. Moment of truth is, do we have a fill? And we do. Looks like we're filling from all over, so I should probably stop that one. Looks like I might need to adjust my hose in there. Alright, so I'm going to have to pull it apart. I think it's leaking from the other side of that solenoid, but I'll take a test that worked. Water is, hookup's working okay. I just need to probably tighten up or Teflon tape the other side of that 12-volt solenoid. So next up is the motor test. I'm going to go forward, which would be clockwise. Okay, tighten up some connections. I think I can hear it clicking. Ta-da! So that's 50%. Pretty good work. Alright, and reverse. Into the neutral switch position. Now, one thing I noticed when I was trying to swap out this motor is there's this crazy mechanism. There's a latch that does two things at once. It takes a tooth or a locking mechanism out of a geared sprocket at the bottom where the agitator and the drum turn, and then it also opens up this drain. I'm going to replace the part that opens up the drain because I've got the 12-volt solenoid on the drain now as well. It'll still gravity feed, but I can at least control that. Problem is, it takes a lot of, I don't know, I guess torque to pull on that lever. I haven't figured out a solution to replace the AC motor with a little wire. It would wind up the wire and pull that away. So for now, I have a patent pending solution here. Ta-da! Maybe. I think it'll hold. So now, when I do the motor, engage it, the whole drum should spin. Cool. All but the fill seems to be working so far. I will try the drain, but this is going to be two-part right now. Let's see. Yep, that's the drain. Okay, so that should be engaging that solenoid. But the other issue is this little valve. Nope. Well, this is a good stopping point for this video. I'll have to do a part 2 to wrap this one up. But as it stands, I started with a 120 volt AC crappy portable washing machine, and I now have a 12 volt DC crappy portable washing machine. I have a manual fill valve for the water. I have a manual drain valve, and I also have forward and reverse on the motor controller. and then a mechanism that for now is very manual but works to do the drain and spin the drum with the agitator for the drain cycle. I've had some successes, I've had some failures, I have more work to do, so I will be back with a part 2 and we'll keep improving upon this. Thanks for watching, and please like and subscribe. Let me know what you think of this in the comments, what you do different, and I'll see if I can make some upgrades. Thank you.